All right, students, this is your task for VEX VR this week. I have three things I want you to do. The first thing I want you to do is I want you to create a program using loops that will take the robot um, through every square using kind of this spiral pattern going around and coming in a square every time till it actually covers all squares. So the first thing we want to do is we want to go into variables and we want to create a variable and we want to make the variable and we're going to call it distance. Distance. Submit. So this is the way to get math to do most of the work. And that's really what we need to be doing in programming. The computer is an amazing calculator. And when I look up HOC programming, it's a higher order calculator. When we're using a computer to do the kind of programming that we're doing, this is what we are doing. We're basically just understanding that computers can do math. So once I've done that, I want to set my variable. So I'm going to pull it in here to here, and you got to make sure it says distance. So click there. And the distance we know is 200 millimeters per square. So that's 9 squares. That's going to be 1,800 millimeters. So that would be the only time that I put the math in. The next time, all the rest of the time, I'm going to be using this distance and then the change distance by um, this. So let's make another variable, and it's called change. And let's start with our change. So set change to negative 200. Negative 200. Boom. So we'll start with that. We'll start with variables, and that way we can make a loop and see how this works right now. So we'll go to a control loop, and we'll do, for this time, we're going to repeat. Then we want to do a repeat 3. So change the variable for repeat to 3. And then we'll go and we want to move forward, drive forward. And now we want to drive forward for a distance. So we'll go get our variable and we want to put it into distance. And then we want to go back up here and we want to turn right 90 degrees. We want to do that 3 times. And finally, for control, we want the program to stop after those 3 iterations. So when we have our board looking like this, we can go ahead and click go, and it should work. And it should stop right here. And it does. So we have the first part of our program created. It takes about 25 seconds to do that. So I'm going to go ahead and reset it. And now let's give it a look. We could go ahead and use a pen so that we can actually draw the direction that we go in. So we're going to come up here, and right after change, we'll go ahead and set robot pen color to black. and we need to move the robot pen down so it's actually writing as it goes. And this time we'll try it again, and this way you'll see that you actually get a legacy or evidence of where your robot's gone. And that is how that occurs. And that's working really well. So now let's take it, let's think like a robot. I am here, and instead of going the distance 1800, I want to burst out of that iteration into going 1800 minus 200. So, what I want to do is I need to create another loop. So once it finishes this third loop, so what I just did is I drug the end program off for just a second, and I'm going to go to control, and I'm going to go to another repeat loop, and this large repeat loop I want to do 8 times. And the first thing I want to do in this repeat loop is I want to go ahead and reset the distance. So I want to go to variables, and I want to put change distance, and then I want to put change into here because we've defined change as negative 200. And then what I want to do is I want to put in another loop for turning. So I want to do this twice. I want to come here, stop. That is moving forward 1800. I'm sorry, 1600. And I want to stop. And then I want to turn right, and I want to go another 1600. So I want to put another loop inside a loop. So I want to go ahead and take this repeat, drop it right in after here, and I want this to be done twice. So it's going to repeat this inside twice 8 times for a total of 16. And now what I can do is I can come up here and I can copy that of this part right here. I want to duplicate it and bring it down. And I want to duplicate it. Okay, I should have brought it that one. I clicked on the bottom one. So it allows you to duplicate both of them and bring it down. And now that's in the wrong place. Oops, don't do that. Grab the top part of it and bring it out. Make it this way. Pull this out, throw it away. Pull this inside. Pull this back up inside here and connect it there. And then I want to end the program. So I need to come back to control, and I want to stop the project when it's done this. So I'm going to go ahead and start this, and then I'm going to cut it out. I'll let it go ahead and finish, because what happens is you're just kind of like watching paint dry. It was kind of fun for a while, but I would rather you guys be working on doing this yourself. So I'm going to go this way, and we'll start, and we'll see if this is going to work. So we know the first iteration works because we already tested it. The repeat 3 times. Now this one should come to this square right here and turn, and it did. And it should go up and it should turn right now, and it does. And then it should come over, and right before this, it should turn again. So we realize now that we have the program that will do all of this for us using mathematical variables. So instead of having to write out every turn, we're able to create repeat steps and use them in closed loops. So closed loops are loops that do not bring into any other, do not bring variables into the loop. We're going to also talk about open loops where we can create something such that if it bumps into the wall, it can stop or it can move a different direction. If the robot is receiving feedback, that is an open loop. If the robot's receiving no feedback but is actually running a program by itself like this is called closed loop. So there we go, 1 minute 43 seconds is what it should take. Now, what we will do is reset it, and we can play with, and I'll let you play with this as well. What do you want the colors to be? Because you set it to black up here, but I'm going to pull this off. And I'm going to pull this out for a second, and I'm going to move everything back. As long as the pen is down, maybe I want to do this iteration in black. So I'll go here and set pen color to black. But these iterations, I want to be in two different colors. So I would have to create this like this and make it one. But I have to copy this, duplicate, and put it right underneath it. And now I can take and set this top color to red. And then I can move it right in here after it turns again and turn it to blue. And I will go ahead and play this, and you'll see how it changes. Now, notice we're repeating this once, but we're actually doing it twice. And the reason why we're doing it twice is to change the color. We could actually create a program for the color to change the color based upon time as well. But you'll see now that that's red, and now this becomes blue. And then this one's going to be red. And the other becomes blue, and I'm going to stop talking because it's like watching paint dry, so I'll cut it out. So the idea of thinking like a robot is we began to think step by step, logic by logic, equation by equation, step by step, logical step by logical step, equation by equation. So that is your first challenge. I'm going to go ahead and end this video, and I'll create one for your second challenge.